Here's where a turbine would go if I had one. No, really, I have it out because I have it in the house. I'm doing some quite extensive modifications to convert it to a turbo housing with stainless steel housing. And we just had a whole bunch of rain after having like no rain for a month, and it's finally, flowing pretty good. It's probably going to pick up even more as the ground soaks up, because the ground is really soaked, and I don't have the water wheel hooked up because I want to do other things to that too for testing power generation and other stuff. Today would have been a great day to test potential power generation off of it, even though I realize it's small. But I also want to, after I do that, build a 5-foot water wheel. So if I extend from that pipe out to here, I should be able to get about 5 feet down to there. You can see the outflow pipe there from the spring is submerged. It's all going down there pretty good. Let's walk up here. You see quite a bit of water is flowing out here. Got some good velocity if I wanted to do something with that. But really, it's not a good idea to put a turbine at the end of a long open pipe, because in an open pipe you have friction as the water flows at high velocity. If you were to close that pipe up with a cap at the end and a nozzle, so the pipe was completely full, you'd have less effective fluid velocity. Oh, there's a watermelon husk. Chickens ate the rest of it. So you'd have less velocity, so you'd have less friction, and you'd get more pressure there and more velocity with the same amount of water. Just as a little tip for you guys. And I'm just going to take my shoes off because I'm slipping there. I'm going to go see if I can unclog that. Right, so it's actually not clogged. I thought it was clogged because there's so much water flowing out here, but really it's just a sharp pipe coming into that culvert, and I have a board there that the pipe's going through. And the intake geometry of a pipe going sharply into a body of water does not allow a whole lot of water to flow. So that's why, even though this end of the pipe is submerged, that the water coming out here is not 100% of a pipe. Instead, we have just a portion of it, because you have a finite velocity coming in, and then it accelerates down the pipe, and as it accelerates, it has to take up less cross-sectional area for the same Q dot. Q dot is volumetric flow rate. So it accelerates and it gets smaller as it speeds up for the same volume of flow. All right, let's get my shoes. I'll have to rinse those off. But also, since we're out here, we can take a look at some of the stuff up here. Pardon all the garden hose, I've been playing around with other stuff. So this is a temporary pond that I built for the ducks. Although we've had it for 6 months now and I haven't done anything to improve it. You can see it's flowing over pretty good right there. There's just a tarp built up against a dirt berm with some logs in it. The water that comes into this creek, part of it flows down there, and the other part of it flows from over here. I've never seen the ducks swimming in there. And that comes out the ground there, but really, yeah, I know you guys are peeved that I'm here. Going up here, there's actually just a ditch that the water comes down the hillside and under this berm, because this was a logging road and it's just eroded to which it's eroded so much away there that it got back down to its original ditch bottom, you could say, which is there, and it goes underneath there. So it found its original ditch going underneath this and eroded a hole out going down there. Alright guys, I've been super busy doing hospital stuff. I have a whole lot of veterinary hospital stuff because we own a veterinary hospital. We got new cabinets, so I was installing them. And now I have to go burn a brush pile at our other property. And then I have for $500 worth of CNC work to do. And then maybe I'll catch up to some other stuff for YouTube. But that's going into like Wednesday of next week at this point. So that's what I have for you. I'll see you guys around. Bye.